Welcome to MRL. In this learning session, we'll be answering the questions asked on different pages of the textbook Ganita Prakash for grade 8th NCERT CBSE syllabus. Now, from each page there are few questions and those questions have to be answered, and we are trying to answer those questions. Now, before you begin to understand the answers for the questions, I suggest you all to go through the basics of this particular chapter, that is squares and square roots, and then attempt understanding the answers for the questions. So let us begin the page 2 of the squares and square roots part of the first chapter of the Ganita Prakash textbook. Now, question 1, page 2. Does every number have an even number of factors? Now let us understand this. 1 is having only one factor, 2 is having two factors, 1 and 2, 3 is having two factors, 1 and 3, 4 is having 1, 2, 4, 3 factors, 9 is having 3 factors, 1, 3 and 9, and 16 is having 1, 2, 3, 4, 5 factors. Now, first of all, what is a factor? A number which divides the given number completely. 1 divides 1 completely, therefore 1 is a factor. 1 divides 2 completely, 2 divides 2 completely, therefore 1 and 2 are the factors of 2. So also the others. Now here we have odd number of factors for 1, even number for 2, even number for 3, odd for 4, odd for 9, and odd for 16. It means that a number can have an odd number of factors or even number of factors. But a very interesting observation here is, if you take the 4, it is a square number, 16 is also a square number, the 4 is having 3 factors and 16 is also having 5 factors. That means both of them are having odd factors. Therefore, we can conclude that squares have odd number of factors. Okay, remember that. Now the question number 2, page 2. Does 36 have odd number of factors? 36 is definitely a square number, therefore it should have an odd number of factors, and the odd number of factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. There are 9 factors which is odd in number. Now coming to the question number 3, page 4, digits and units place of squares. The digits and units place of squares are 0, 1, 4, 5, 6 and 9. Remember that. The question number 4, page 4. If a number ends in 0, 1, 4, 5, 6, 9, is it a square? Is it confirmed that the number will be a square number? Now, the conclusion is that it may or may not be a square number. For example, 16 is a square, 6 is the digit, so 16 is a perfect square. 36 is also a perfect square because 6 is the digit in the units place, but 26, although it is having the digit 6 in the units place, it is 100% not a square. Therefore, it is these are not sufficient conditions. Therefore, having these digits in units place does not decide that a number is a perfect square. We have to verify and confirm it. Now, coming to the question number 5, page 4. If a number ends in 2, 3, 7 or 8, is it a square or not? A number which ends in the digits 2, 3, 7 or 8, it will not be a square at all. It will be a non-perfect square, and it is a sufficient condition. If a number has a digit 2 or 3 or 7 or 8, we can straight away declare it is that the number is a non-perfect square. We don't have to even verify it. Now come to the question number 6, page number 4. Write 5 numbers such that you can determine they are not squares by their units digits. Very simple. Just put these digits in the units place 2, 3, 7 or 8. That's what I have done here. 1, 0, 2, 2 is the digit in the units place, non-perfect square. 8 is the digit in the units place, therefore not a perfect square. 7 is the digit in the units place, therefore not a perfect square. Again 3 in the digit in the units place, not a perfect square. So all these numbers which I have listed have the digits 2, 3, 7 or 8, and therefore none of them are perfect square. All are non-perfect squares. Remember that. Now coming to the question number 7, page number 5. Chart of unit digit of numbers and unit digit of squares. Now what does this mean? So let us say we have the numbers ending in units digit as 1 and or 9, then the squares will have the digit 1 in the units place. If the numbers end in 2 or 8, the squares will have the digit as 4 in the units place. If the numbers have 3 or 7 in the units place, then the squares will have the digit 9 in the square in the units place. 4 and 6 are the digits in the units place of numbers, then 6 is the digit in the units place of the squares. If 5 is there, then 5, 0 is there, then 0. If I take a few examples here, if you take 14 square, 4 is the digit in the units place, 4 is the digit in the units place, then the square will have 6 and it is 6. Now if I take 15 square, 5 is the digit in the units place, 5 should be in the square and therefore it is 5 there, 225. If you take 18 square, if 8 is the digit in the units place, then the square will have the 4 in the digit, 4 as the digit in the units place, and it is 4. So therefore remember this chart, remember the digits. If very simple to remember, 1 square of 1 is 1, therefore 1, square of 9 is 81, therefore 1, square of 2 is 4, therefore 4, square of 8 is 64, therefore 4, square of 3 is 9, therefore 9, square of 7 is 49, therefore 9, square of 4 is 16, therefore 6, square of 6 is 36, therefore 6, square of 5 is 25, therefore 5, and square of any number 10 square, it is 0, therefore it will be 0. A very simple way of remembering, so try to remember them. Now question number 8, page number 5. Number of end zeros of a number and its square. If you take a number 10 square, the square of 10 square is 100, so 1 0 2 zeros, 1 0 2 zeros. 700 square is 49 followed by 4 zeros, therefore 2 zeros are there, there will be 4 zeros, and therefore remember a square number has even number of end zeros, 2 zeros, 4 zeros, 6 zeros, and so on. Now question number 9, page 5. What can you say about the parity of a number and its square? If you take a number of 2 digits, then its square will have 2 pairs. See, there are 2 pairs here. One pair, there is 0 forms 1 pair and 1 forms 1 pair. So if there are 2 digits, the square will have 2 pairs. If there are 2 digits, the square will have 2 pairs. If there are 3 digits, and then the square will have 3 pairs. So number of digits, number of pairs. How many digits? Those many pairs. So remember that. Now coming to question number 10, page number 6. If 35 square is equal to 1225, find 36 square by adding 36 odd number. A very simple thing. First of all, we are given that 35 square is 1225. Now we have to find the 36th odd number first, and the odd number, nth odd number is given by the formula 2n minus 1. So 36 odd number will be 2 into 36 minus 1, and that is 71. Now add this 71 to 1225, we get 1296, and 1296 is 100% square of 36. So 36 square is 1296. So therefore remember, 36 square is equal to 35 square plus the 36th odd number. A very interesting and important way of finding it. Now come to the next question, question number 11, page 7. Find how many numbers lie between 2 consecutive perfect squares. Now for example, we have 2 consecutive square numbers here, 2 square and 3 square, and 2 square is 4, 3 square is 9. Between 4 and 9 we have got 5, 6, 7, 8 which are non-perfect squares. Therefore 2 into 2 is 4, that means 2 into 2 is 4 non-perfect squares. Take 4 square and 5 square, 4 square is 16, 5 square is 25. The numbers between 16 and 25 are 17, 18, 19, 20, 21, 22, 23, 24. Therefore 8 numbers. The method is very simple. 4 into 2 becomes 8. So generalization is, if we have two consecutive square numbers, that is n square and n plus 1 whole to square, the number of non-perfect squares between these two perfect squares is 2 into n numbers. Therefore the number that lie between two consecutive square numbers is 2n. Remember that. Now the question number 12, page 7, it is you can just yourself do it. How many squares are there between the following numbers? The numbers are 1 and 100. So write down the squares between 1 and 100. 4, 9, 16, 25, 36, 49, 64, 81, 8 squares. Similarly, the square numbers between 101 and 200. So 4 squares. 201 and 300, 3 squares. 301 and 400, 2 squares. That you can try yourself and understand. Now coming to the question number 13, page number 7. Can you see any relation between triangular numbers and square numbers? 100% there is a relation. Now first of all, we know what is a triangular number and how to find triangular numbers, and the sum of the consecutive triangular numbers is 100% a square number. For example, the first triangular number is 1, second triangular number is 3, 1 plus 3 is 4, therefore it is 2 square, and we have the triangular number that is 6 and 10. So 6 and 10 is 6 is one triangular number, 10 is another triangular number. When we add, we get 16, that is 4 square. When we add 3 and 6, we get 3 square. 10 and we get 10 and 15, we get 25, that is 5 square. So like that, we have the sum of consecutive triangular numbers as a perfect square there. So remember that. Question number 14, and please go through the basics of this particular topic in the video which is already there available on this channel. Now question number 14, page 7, the area of a square is 49 centimeter square. What is the length of its side? We are given a square here, its area is given, and area of a square is L into L. Therefore L into L is given as 49, so L has to be 7 into 7 is equal to L into L. Therefore L is 7 centimeter. Or in the simple thing is just find the square root of 49, that will be the length of the square, and that is the answer. What is the square root of 64? 8 into 8 is 64, minus 8 into minus 8 is 64. That means the square root of 64 can be 8 or minus 8. Therefore square root of 64 is plus and minus 8. Every number has two square roots, but we take only the positive value. Now is question number 16, page 8, is 327 and 576 are perfect squares. Now 327, 7 is the digit in the units place, 100% it is a non-perfect square because 7 is the digit in the units place here. Now 576 may be or may not be, 6 is the digit, definitely it can be or it may not be, but we have to confirm it by finding out the factors of 576. We go for prime factorization. So when we carry out the prime factorization of 576, we find 1, 2, 3, 4 pairs of 3 pairs of 2 and 1 pair of 3. Once there are 3 pairs of 2 and 1 pair of 3, that means all the prime factors are in pairs, and therefore 576 is 100% a perfect square, and 576 is equal to 2 into 2, 4, 4 into 2, 8, 8 into 3 is 24, so 576 is 24 square. So please understand this. To find out whether 576 is a perfect square or not, first of all it may or may not be a perfect square because 6 is the digit in units place. And if 6 is there, it can be the digit, the number will be ending in 4. The units number will be 4. So 576, the unit number of the number will be 24, that is 4. So therefore, because we know 6 6 is 36 and 4 4 is 16, it can be 6 or 4. But now by prime factorization, we have found out that it is 24 square. Now is 324 a perfect square? Again a very simple question. Write the factors of 324. So prime factors you have found out, it is 2 into 2, 3 into 3, 3 into 3, all are in pairs, and therefore 324 is a perfect square, and 324 is equal to 2 into 3 into 3, 3 is 9, 9 to the 18, remember that. Now coming to question number 18, page number 9, is 156 a perfect square? Again a simple question. Take 156, prime factors of 156 are 2, 2, 3, 13. Now all are not in pairs. Therefore it is not a perfect square because the factors are not in pairs, and therefore it is not a perfect square. Now find whether 1156 and 2800 are perfect squares using prime factorization. So for 1156, find the prime factors. It is 2, 2, 17, 17. Their factors are in pairs. Therefore 1156 is 100% a perfect square, and it is 17 2s are 34 square. Now 2800, find the factors of 2800. We get the prime factors here. 1 pair of 2, 2 pair of 2, 1 pair of 5, and 7 is single. So since 7 is single, it is not in pair, it means all the factors are not in pairs. Therefore 2800 is not a perfect square. Now go to page number 8 of the textbook. We have got many examples in the section figure it out. The first example is to find non-perfect squares. To find non-perfect squares from the given numbers. Now 2032. The digit in the units place is 2, 8 and 7, therefore 100% they are non-perfect squares. There is no doubt about that at all. Okay. Now come to find the numbers with units digit as 4 in their squares. Now it's very simple to understand. 8 square is 64, the 4 is the digit in units place. 2 square is 4, again 4 is the digit in units place, and therefore 108 square and 292 square will have digit 4 as the last digit. Remember that. Now given 125 square is 15625. Now we have to find out 126 square. That means the next square number we have to find. So therefore find out 126th odd number first. Now to find 126th odd number, we can use the formula 2n minus 1. So 2 into 126 minus 1, 252 minus 1, 251. Therefore the nth odd number, because since the nth odd number is 2n minus 1, we got the 126th odd number as 251. Now add this 251 to 15625. That means 126 square will be equal to 125 square plus 126 odd number. So 15625 plus 251 is the answer for finding out. That is the answer of 126 square. We can add that and get the answer. Now the next question is, you are given area of a square as 441 meters square, and area of a square we know it is length into length or side into side. So side into side is area, L into L is 441, so L will be equal to square root of 441, and finding the factors of 441 we get 3 into 3, 7 into 7. That means we get 3 into 7, the square root of that will take one factor each, 3 into 7 and it's 21, so the length of the square is 21 meters. Now the next question is to find, that is the fifth question, to find the smallest square number that is divisible by each of the numbers 4, 9 and 10. Now first of all, a number which is divisible by 4, 9 and 10 is the LCM of 4, 9 and 10. So find the LCM of 4, 9 and 10. When we find the LCM of 4, 9 and 10, as you all, I believe that you all know how to find the LCM. So 4, 9, 10 LCM when we find the LCM is 180. Now find the prime factors of 180. When we find the prime factors of 180, we get 2, 2, 5, 3, 3. That means 2 are in pairs, 3 are in pairs, but 5 is single. So 5 is single here. So 5 is single. If 5 is single, that means the factors are not in pairs, therefore 180 is not a perfect square. Now they are asking us to find the smallest square number that is divisible. So therefore we have to make this 180 a perfect square. To make 180 a perfect square, I have to multiply it by 5. So 5 is single, I have to multiply 180 by 5, and when we multiply 180 by 5 we get 900. So 900 is the smallest square number which is divisible by 4, 9 and 10, and 900 is 30 square. So please remember this, and a very simple method which you have to remember. Okay, now let us go further. Now the next question is to find the smallest number by which 9408 must be multiplied to obtain a perfect square. Also find the square root of the number obtained. Now first of all, 9408 is given to us. Let us find the prime factors of this. When I find the prime factors here, if we get 1 pair of 2, 2 pair of 2, 3 pair of 2 and 1 pair of 7, and 3 is single. So 3 is single here, that means the factors are not in pairs. If the factors are not in pairs, that means 9408 is not a perfect square. 3 is single, therefore I have to multiply 9408 by 3 to make it a perfect square. So when I multiply 9408 by 3, I get 28,224, and now we have to find out the square root of 28,224. It's very easy. Square root of 28,224 will be 1, 2, 3 pairs of 2, 1 pair of 3 and 1 pair of 7. Pick one factor from each pair. I get 2 into 2 into 2 into 3 into 7. That will be 2 to the 4, 4 to the 8. It is 24 into 7, and that is 168. Therefore square root of 28,224 is 168. So that is the method. Now coming to the next question, to find the numbers that lie between the squares of given numbers. Now the 16 square and 17 square are two consecutive square numbers. The number of non-perfect squares between these two are 2 into n, and therefore it is 2 into 16, and there is 32 numbers lie between 16 square and 17 square. If you take 99 square and 100 square, now to find the number of factors between these two, it is 2n, and therefore it is 2 into 99, that is 198 numbers lie between 99 square and 100 square. I suggest you all go to the basics to understand the solution of these examples. Now coming to the 8th example, in the following pattern, fill in the missing numbers. So these are patterns of numbers given to us. We have to fill in this, the way which I have written with the red ink there. So now if you observe very carefully, if it is 12 it is 13, if it is 6 it is 7, if it is 2 it is 3, if it is 12 it is 30, next number, if it is 20 it has to be 21, and here 4 into 5 is 20, 3 into 4 is 12, 2 into 3 is 6, 1 into 2 is 2, 9 into 10 has to be 90, and next number is 91. So therefore the numbers are 21, 90 and 91. So please understand this pattern and fill them. Now to find tiny squares from the picture and write the prime factorization of the number of tiny squares. So in the picture we have total number of big squares are 9 into 9, 81, because there are 9 columns and 9 rows. Number of tiny squares in each big square is 5 into 5, that is 25. Therefore the total number of tiny squares in the picture is 81 into 25, that is 2025, and the prime factorization of 2025 will be the 3 into 3 into 3 into 3, that means 2 pairs of 3 and 1 pair of 5, that is 3, that is 3 raised to 4 and 5 raised to 2. So that is the prime factorization of the tiny squares of the picture which is there in the textbook. Now we have learned, or we have rather answered all the questions from page number 1 to 11 related to squares and square roots of the topic square and cubes of Ganita Prakash, grade 8th textbook of CBSE textbook, then the new textbook, the NCERT textbook. So go through these questions and understand them, and note down them in a book and revise them so that you can easily answer them. But what I suggest is, before you go through these questions and answers, learn the basics first, apply those basics, then it will be very easy for you to understand. Thank you.